Well, thank you all for joining us today. Today's presentation has 4 sections. The first section is on telematics, cellular modems in cars. The second section on infotainment. Third section on ADAS, advanced driver assistance systems. And the fourth section is on PCIe for automotive. So telematics, 2G, 3G, 4G, 5G cellular. So this is an overview of Anritsu's key products for telematics, especially 5G. So for 5G, we have this MT8000 call box that gets used for chipset R&D. It gets used for RF test. It gets used for functional system level test. It gets used in our RF conformance systems, in our protocol conformance systems, and in manufacturing solutions as well. Also shown here at the top is the MP1900, which is our PCIe tester we'll be talking about in the last segment of today's call. To cover the 2G, 3G, 4G, we have separate boxes for chipset and R&D, RF test, and functional test. And we've just, within the last few months, we've added 4G capability into both our RF test GUI, our protocol scripting GUI for chipset R&D, and our functional test GUI. And all of these solutions support both 5G FR1, which mainly is what is used for automotive, and then the FR2 millimeter wave, which currently is not really targeted for automotive so much, with the small cells used more for cell phones in small areas at downtowns or stadiums. So to support testing of telematics with our functional test solution, we can do cellular function tests such as handovers between any different cellular technology. We can do throughput testing, power consumption, and how much current does the thing draw, especially when you've got it configured for maximum throughput. We can do server application testing, where we connect our simulators to the same type of back-end servers that the car would connect to on the live internet. Various manufacturers have their own services, like GM has the OnStar, and Ford has the Sync, and different other back-end services. So we can test as if it was connected to the back-end servers, where they can send commands to unlock the doors or read the information off the CAN bus of the car if it's having some problems or whatever. We also support in our functional test system doing the eCall testing, which is a technology I'll be talking a little bit more that's used in Europe, and a version of it that is used in Russia, and new versions in other countries are popping up all over as well. We don't have this in the US, but I know a lot of companies in automotive are developing things here in the US for the global market. We also have a solution for doing vehicle-to-vehicle, vehicle-to-infrastructure functional testing. This is a new technology that hasn't really come to mass fruition yet. We can do most automobiles, the modem in them use an eSIM, electronic SIM, instead of a removable SIM like we have on most phones. And we have a way, we partner with various vendors such as Compreon for being able to do eSIM testing. We can also do cybersecurity testing with our system, where our equipment acts as the data pipe and can connect to the IP layer for cybersecurity testing. We partner with companies like Head Acoustics for audio quality testing with our systems, and we partner with companies like DSpace for hardware loop testing. So for eCall, the original eCall version was the European version that uses GSM and WCMA 2G, 3G, and it was mandatory for all new cars in Europe as of March 2018. There's a new version of it called NG112 that the mandatory date is not yet fixed, that uses LTE instead of 2G, 3G for the system. They're also looking at it in Turkey and Israel. There's a version of it called ERA-GLONASS that is for Russia, and that was mandatory in January of 2017. There's another UNR, which is United Nations eCall, that is now in effect, and it's basically the same as the European eCall. There's a Japanese eCall, a South Korean eCall. We just introduced an option in our system for supporting that. The Gulf Coast countries, it uses something very similar to the European eCall. And the China eCall is also another 4G one that's coming down the pipeline. So the way eCall works is when a car, let's say a car is in an accident, it crashes. The car gets the GPS location data, and it sends it in a message called the MSD over in-band signaling over the audio path over a WCMA or GSM network, and it sends it to the emergency call center, the public service answering point. If they had this in the US, you'd call this the 911 center. And the 911 center gets all this data of where the car is, the location, how fast it was going before it crashed, what direction it was heading, what size vehicle, what type of propulsion, all different stuff like that. And then once it gets all that data, it opens up a voice call into the cockpit of the car to ask if anybody's hurt, so they can get an ambulance there quicker and save lives before people die in the accident. So we simulate all this using our 8475B base station simulator, and we connect it to the cellular modem, the in-vehicle system of the car. And then running on Windows, we have the PSAP simulator that is able to read all the data that comes in and so forth, and simulate the PSAP. So for the Russian ERA-GLONASS testing, they require to do testing with the ERA-GLONASS using an eSIM. So typically, the SIM card that's programmed in there is for the live networks. To connect to a test system, we have to use a test SIM where we have known authentication keys that we can enter into our tester, and it will authenticate with the SIM in the vehicle. So we use the tools such as a Compreon profile manager, and with the profile manager, it's able to switch from the live network profile to a test profile that we can connect with our testers. So we download that into the eSIM, we enable that test profile, we do our testing, and then we switch it back to enable the original profile and delete the test profile. So Anritsu has various options and some unique capabilities. We have optioned the standard, the base eCall supports the 2G, 3G European eCall. You can add on to that the option for the Russian ERA-GLONASS, or you can add on to it the 4G eCall that's not yet mandatory. And we revalidate our solution every year with a test house. So we have a certification. You can use our system for certification testing, and they actually do vehicle crash testing where they destroy a vehicle to test this eCall system to make sure, even though it's crashed, it hasn't destroyed the modem or the cables to the antenna or whatever, and it's still able to work. So some of the unique options, we recently added the South Korean eCall. We're the only test solution for that today. We're the only solution that supplies the ERA-GLONASS, all the EGTS server requests. So they have in the ERA-GLONASS system, they have a way for the call center to send particular requests to get particular types of information. We also, in our 4G eCall, we added an option for semi-normal testing where we can do things out of the ordinary to see how the device deals with those things. And we have an option that's unique to support multiple cells while in eCall mode. So what we can do is we can have 2 GSM cells and or a WCMA GSM cell and see which one it uses when the eCall happens. You can be in an LTE call when the 2G, 3G eCall happens, and it does a circuit switch fallback, CSFB. So we have a lot of unique capabilities with a very popular eCall solution. So we also have various other things. So mobility testing is one of the things that is common commonly tested on the automotive telematics control units, or TCUs. Various combinations of different 2G, 3G, 4G technologies and 5G and so forth, being able to do handoffs and cell selection and roaming testing. Being able to do throughput is important, especially for 5G. You can also test how the device is heating when it's fully loaded up to the max throughput. We have a built-in server PC in the 8475, or you can use external server PCs as well. It has a measure function that can measure all the ACs and NACs and the coding schemes that are being used, the modulations, throughput monitors. It'll monitor both the MAC layer throughput as well as the IP layer throughput. An RF monitor that can measure the channel power and the frequency and so forth that you're on, and counters for all the ACs and NACs and DTX frames. Also, in both our 2G, 3G, 4G, and our 5G solution, we can do test some network behavior things. We can do network reject testing. So how does the device react if it gets a connection reject with a certain reject cause? A lot of times these are situations that happen very infrequently in the live network and are very almost impossible to duplicate on the live network because they happen so infrequently. But you can set these up with our network simulator right from the GUI without having to write any complex scripts. We can also do the end-to-end service test. As I mentioned, we can connect our simulator to the same backend server or a simulated version of the backend server that the mobile device in the car connects to at the automaker. We can support the voice over LTE or the voice over 5G, voice over NR capability. It's a built-in IMS server in our functional test system. And as I mentioned before, we can do tests for cybersecurity. You can use our system as an IP pipe basically, and you can do various testing back on the IP layer. So the vision that we see for testing these telematics control units, the most basic testing is just testing the TCU module on the bench connected to the equipment. Here's the RF test setup or the functional test setup. And this is done both at the TCU supplier level as well as the automotive OEM. There's the service evaluation. This more than likely is done at the automotive OEM, where in addition to the TCU, they have like a dashboard simulator or head unit simulator that has the GUI that the person in the car would see for the cellular modem to place a call and so forth, and they can connect it to the backend servers or server simulator, or they have a more enhanced version of it that maybe has a steering wheel, has a maybe an on-off key and things like that you can do further testing. And then there's the hardware in the loop system that they will use things like the DSpace ECU simulators. You can simulate the ECUs or the backplanes of the vehicle, and they can actually have the powertrain and the drivetrain connected in. I've seen some of these systems where you actually can see the drive-by-wire moving servos and stuff. They have all the electronics of a vehicle hooked up, and they can add in our network simulators into those hardware in the loop systems. And in the future, we're looking at developing systems, especially for autonomous vehicles, of doing software in the loop testing. And this allows us to do a lot of the same kind of things we do in hardware in the loop, but we eliminate the hardware and we're just testing the software. So everything is more of a simulated environment that allows you to do much earlier in the development process before the hardware is ready. So for autonomous vehicle designs based on hardware in the loop testing, one of the other type of things that 5G adds, it adds something called network slicing. And with network slicing, you have this thing called the NSSAI, the network slice identifier, and it has different slice service types. So you could have one slice for enhanced mobile broadband, and enhanced mobile broadband is basically like high-speed internet. So in a vehicle, enhanced mobile broadband is often used for downloading firmware into the vehicle, or maybe even a hotspot in the car. Maybe the kids in the back seat have an iPad and they're watching Netflix. There's also can have a separate network slice that is not interfered with by the bandwidth or constraints of what's going on the other network slices for ultra reliability, low latency. If you have, especially in an autonomous vehicle, if the automaker is making any decisions for the autonomous car in the cloud, you need very low latency. There's also this cellular V2X system that is being developed, can have its own slice. So we have the capability in our network simulators for simulating this network slicing. And with network slicing, they have another technology that is tied to that, is called MEC, or mobile edge computing. And with mobile edge computing, the server that the service in the vehicle is connected to is not the kind of thing where there's one server somewhere in the country or somewhere in the world and has to connect all the way across the internet to get to it. With mobile edge computing, they might have a server in every major city to reduce the latency, or maybe a mobile edge computer. I've seen some tests that they're doing in various places where they put the mobile edge compute right at the street lights within a city, and they can get much lower latency for the back-end services, or for the enhanced mobile broadband, the hardware, the high definition map updates, software updates, or the V2X hazard warnings, and so forth. So a little bit more about our 5G network simulator, the MT8000. It can install up to 10 different firmware versions on the one instrument, and we have different firmware versions for different applications. So for protocol scripted tests, there might be one firmware version, or maybe you have the current version and a previous version installed. For the functional test, you might have a couple of versions of that installed, or for the RF test. So we can have one PC and one box that can do all these different applications depending on the software you've installed and the licensing that you've paid for. So just a little bit more about the three different GUIs. For the automakers, the most popular GUI is this functional test, SmartStudio NR. They typically, the automakers rely on the TCU suppliers to do the RF testing. So if you're a TCU supplier, you might use both the functional test and the RF test GUI. The rapid test designers typically use more at the chipset level, at like a Qualcomm or MediaTek or whatever. So we have this advanced architecture for both software and for hardware. We have a modular system, so we can configure for different use cases depending on how much carrier aggregation and MIMO you need, and different other things like that. We can add or remove hardware cards and upgrade as new bands are developed. We can just swap out an RF card. So one of the challenges for functional testing and regression testing of a TCU is it takes a lot of high-level skills to do the troubleshooting. It takes a lot of development to fully configure to automate the systems, and to write software to automate the systems for testing, and to maintain all those test cases. That incurs a lot of cost, and then it requires investigation costs to design the test environment and the test times. And with the latest devices in 2G, you typically had 2 bands. In 3G, you might have 3 or 4 or 5 bands. In LTE, there was many more bands, so you could have a device that might support 5 different bands of LTE, and it might support several different bands of 5G. So when you add up all these combinations, it could be over 2,000 combinations of different bands that need to be tested. And with that many combinations, writing all those test cases and maintaining it all is more than most people do. So you end up having a lot of things that are not tested or not regression tested. So we've developed a new tool called SmartStudio Automotive Suite that's unique in that you don't have to configure it. It automatically reads the UE capability from the TCU of what bands it supports and the configurations, and automatically configures the test and automatically generates the test. So you don't have to create test cases. Automatically generates them based on the device's capabilities. It also has the capability of analyzing the log and suggesting what the cause is when we've seen similar things happen in the log, what the problem was that caused that problem. So it reduces the skill level for the debug, and it saves off all the logs and saves off all the results with graphical charts. In the future, we're looking to integrate the back-end service level testing, the hardware in the loop testing, and C-V2X, as well as maybe handover testing. Currently, we can test all the band combinations and the throughput. So it can be used at the chipset module level, at the integration regression testing level, at the service level test or end-to-end testing. So all these different areas of lab tests, you can use a system like this. And this is a little bit what the GUI looks like. It shows a chart after it's read all the UE capability reports. It shows you which bands in LTE it supports, which bands in 5G it supports, and then it creates a spreadsheet type list of all the possible combinations of test cases. And then you can check which one of these, check these little box of which ones you want to run, and then you just hit the run button. With so many combinations, you can also, just like a spreadsheet, you can do filtering. So you can filter if it includes a certain band or doesn't include a certain band or a certain channel bandwidth. So there's filtering you can do to make it easier to sort out the test cases you want to run if you don't want to run all. If you want to run all of them, it could run for maybe days or even a week to get through all those. It can run fully automated and control the device under test. So this shows an example of the GUI for the throughput testing. We can do both the LTE and the 5G throughput automatically. And it generates a report and a log file. Here's an example of a report. It shows the number of passes, the number of fails. It shows different configurations. It saves off all the log files and all the setup files that it used. So it's quite complete. To connect this system up, you have our 5G network simulator and our 4G network simulator, the 8475. You're connected to the TCU, the in-vehicle device. We're also connected to a server PC for doing the throughput testing and a control PC to run the control software for the MT8000 8475 and this SmartStudio Automotive Suite. So it captures the UE capability information. It automatically creates the test cases. It runs the test, gives you a pass-fail, and generates a report and saves off the logs. So in summary, this SmartStudio Automotive Suite, it minimizes investigation cost, eliminates a lot of the training needs, eliminates the information of what bands need to be tested. It minimizes development cost. It makes debugging efficiently as it automatically analyzes the logs and suggests what the issues could be. And it offers upgraded extendability for autonomous driving in the future. So beyond 5G and 6G, so the use cases are not clearly defined yet. They're only just starting to define them. Industry and academia is evaluating the progress of 5G as it advances and to see the possible evolution beyond 5G into 6G. So 6G target is to bring capabilities that currently are not possible in 5G, much higher data rates, much lower latencies, and probably much more in the area of artificial intelligence and things like that. And they're looking for both a business value and a societal value enhancement within 6G. So societal environmental benefits are things we're looking at: expanding differential services with novel experiences, things that are necessary to create and deliver enhanced value. This is from NGMN, Next Generation Mobile Network White Paper. So some of the central themes: digital twin, physical, digital, biological worlds converging, cyber and physical convergence, real-time immersive 3D experiences, full holographic images. Some of the core technologies. Currently, the 4G was all sub-6, and the 5G, they have both the sub-6 and the millimeter wave. And for 6G, they're looking to go to terahertz frequency. So currently for millimeter wave, we have 5G in the 28 gigahertz and 39 gigahertz band. Terahertz frequencies could be, 170 gigahertz, 300 gigahertz. So much higher frequency. At those higher frequencies, there's much more bandwidth to get the much higher data rate. And there'll be new modulation, probably new modulation encoding schemes and new channel modeling and new types of MIMO to adapt to the terahertz frequency. They're looking to improve the spectral efficiency at the sub 6 gigahertz, the frequency range 1, adding virtual MIMO, advanced spectrum sharing, AI, designed into the cellular architecture, distributed computing, using cloud native RAN for more flexible processing and dynamic sharing, 3D, maybe satellite. Actually, this is actually in 5G in release 17 and 18. They're developing what they call non-terrestrial networks. So instead of the cell site being on a tower, the cell site might be on a satellite or maybe on a high altitude platform, like a high altitude drone type thing that's flying around, providing coverage. And there'll be new test and measurement technology we'll need to adapt to these core technology evolutions. And Anritsu already has technology in the terahertz frequencies today. So some of Anritsu's contributions for the new mobile society: we have a high level of knowledge of the telecommunication test. We have a history of contribution for telecommunication with the OEMs, the tier ones, the chipset suppliers. We have these automation tools, the V2X. We have partnership with industry leaders to collaborate to develop these hardware in the loop systems and the C-V2X. We have the regulatory tests for global regulation for like eCall and ERA-GLONASS, and Japan eCall and cybersecurity. The next topic I want to touch on is infotainment. So infotainment is the typically it uses the Bluetooth and Wi-Fi technologies to provide information and entertainment in the vehicle. So of course the Bluetooth would connect to a cell phone, and the Wi-Fi in the car could be a hotspot, as I mentioned. You could have kids in the back could have a tablet watching entertainment on Netflix or Amazon Prime or whatever. So Anritsu solutions for Bluetooth and Wi-Fi, up here for Wi-Fi, we have the 8862, which has full signaling or network mode for both testing an access point or a Wi-Fi device. We could simulate either one. We've recently added the support in this box for the new Wi-Fi 6E band up to 7.125 gigahertz. For manufacturing and non-signaling tests that requires chipset control, we have the 8870, which can do both Wi-Fi, Bluetooth, and cellular in a non-signaling, more of a lot of times in manufacturing or a lower cost R&D setup. And then for Bluetooth, we have a standalone Bluetooth tester as well that has the network mode for the basic rate and enhanced data rate modes of Bluetooth, and then the more of a test mode type for the Bluetooth low energy. And it supports all the way up to the latest Bluetooth spec, including the angle of arrival, angle of departure, Bluetooth long range, and Bluetooth 2 megabit. So the 8870, now supports, it also now supports up to 7.3 gigahertz to cover the Wi-Fi 6E band. It supports all of the 2G, 3G, 4G, 5G for frequency range 1. It supports all of the Wi-Fi, including the 802.11p for the V2X. It also supports the cellular V2X, and has support for GPS. And it has high density. We can test 4 devices at once or 4 technologies simultaneously, very high speed and very expandable. The 8862, it supports ABGN and AC 80 megahertz in SISO. Can support 802.11 AC on either 80 or 160 megahertz in SISO. It can support 11AX up to 150 megahertz. We can support AC 80 megahertz in MIMO with 2 boxes. And it supports both network mode for simulating an access point for testing a device, a Wi-Fi device, or can simulate a Wi-Fi device to test an access point. And it has direct mode for non-signaling mode with the chipset level control and chipset calibration. There's also an option to do Wi-Fi security, which is mandatory for the Wi-Fi 6E band. And you can get it with the 2.4 and 5 gigahertz, or you can add on the 6 gigahertz band for the Wi-Fi 6E. It has a simple GUI. There's no software to install. You connect to any PC of any operating system, open up a web browser, and browse to the IP address of the box, and the GUI comes up with no software to install. And we can capture Wireshark logs for debugging signaling, and we can even test with actual IP data flowing through from the internet or from an external server. Our Bluetooth tester, the 8862, is the world's best-selling Bluetooth RF tester. It's in full compliance with the Bluetooth spec. It's approved by the Bluetooth SIG. It has an embedded protocol stack for basic rate and enhanced data rate. It supports direct mode for Bluetooth low energy. Supports all the way from Bluetooth versions 1 to 5.1 or even 5.2. There's really no changes in version 5.2 over 5.1 for RF testing. It has to automate tests. There's control software that can run on an external PC to automate the testing, get graphical displays. And we support basic rate, enhanced data rate, Bluetooth low energy, 2 megabit, Bluetooth 5.0, BLE, Bluetooth 5.0, Bluetooth long range, angle of arrival, angle of departure. We have customers that use this for making the systems that also they put sometimes Bluetooth in a key fob of the car to unlock the doors and so forth. Next one, ADAS, Advanced Driver Assistance Systems. We have solutions for radar and cellular V2X. So for radar, we have a band-specific VNA that covers the automotive radar band, covers the 77 and 79 gigahertz radar with frequency coverage of 55 to 92 gigahertz. We also have other models that go up to 110 gigahertz and higher for the next generation automotive radar that they're looking at, up to 110 gigahertz. There's 2-port and 4-port versions available. It has a built-in PC. You just connect a display. If you want to put this in an OTA chamber for measuring the radar in an OTA chamber, we've got a version with very long cables where you can put the millimeter wave heads right on the antennas. So it's used a lot of times for testing the automotive radar as it transmits through the various materials, the bumper or the radome or the logo in the front grille or whatever. Need to measure the loss and deflection, the emblems and the bumpers, and even the paint can have an effect on how the radar shoots through the bumpers and so forth. So it can cover the 77 and 79 gigahertz with this one model. Also, we have a spectrum analyzer. It's quite amazing. It fits in the palm of your hand, weighs less than a pound. Can even actually mount it on a drone if you wanted to. It can be used to measure the FMCW chirp characteristics of automotive radar. So we have models that cover the 110 gigahertz model would be the one I would recommend for the 77, 79 gigahertz automotive radar. 90 gigahertz costs the same as 110. It's just for some countries, we're not allowed to sell millimeter wave up to 110 gigahertz to certain countries. So it's fast squeeze speed, wide dynamic range, and allows you to. We have a YouTube video on testing the automotive radar with this box as well. So for cellular V2X, the frequency band for this was in the 5.9 gigahertz band. It was originally 70 megahertz that was allocated about 20 years ago. And the automakers were so slow to adopt this technology. In April of 2020, the FCC gave the lower 45 megahertz of that band for Wi-Fi use. So we expect there's going to be a lot of interference issues with Wi-Fi jutting right up against this safety-related technology. So we have a real-time spectrum analyzer that can do the interference hunting and find these interferers. We have remote spectrum monitors that you can park outdoors and do long-term interference studies and even triangulate where the interferers are coming from. And for C-V2X Lab Testing, the 8870 can support both manual and automated testing. It has chipset-specific drivers. It supports the OmniAir is an organization that does the C-V2X certification, so we can do some of the OmniAir RF tests. And we also have the MX72500A for C-V2X functional testing for testing these various C-V2X messages like forward collision warning, intersection collision warning, blind spot warning, stationary vehicle warning, emergency brake warning, emergency vehicle warning, green light optimization, speed advisory, and so forth. Now I'm going to turn it over to my cohort, Mr. Goto-san. Goto?
Yeah, thank you very much, Craig. Thank you everyone for joining today's. Can you go back?
Oh, sorry.
Okay. Today I'm going to present how a PCIe and Annitsu can contribute to automotive industry. Next slide, please. So Supercar, cars technology is getting better and better almost every day. So Supercar needs super drivers. Actually, in this picture, all drivers are the best of the best of the best, he said. However, actually, my wife needs Supercar. High school students need Supercar to drive the car without any traffic accident. Next slide. No super driver is required. The CPU or silicon chip can take it over. And I'm going to explain why the PCIe high-speed serial bus interconnect on the backplane is the best. Today's domain architecture and in the near future zone architecture need a large traffic on the backplane. The zone traffic, I had to drive the car without any traffic accident. You need maybe 20 sensors or cameras, and then each camera needs a very high resolution like a 4K TV, so a large traffic. In the both case, domain architecture or zone architecture, PCIe is one of the best candidates because, next slide please. The requirement is needs to handle massive data traffic, the large bandwidth, low latency, and scalability and expandability because of the automotive, and reliability and stability. PCIe can meet all these requirements. You can see the table. The revision 1 of PCIe, it's like 20 years ago, 2.5 gigabit per second speed per lane, and you can configure single lane, quad, 4 lane, 16, or 32 lanes. Currently, 3.0, 4.0. 3.0 is quite matured. It's almost 10 years ago. Actually, 11 years ago, it is released. And PCIe 3, 8 gigabit per second per lane. It's very mature technology. Now 4.0 is coming, that's 16 gigabit per second per lane, and the new technology is 5.0. Now official test, compliance test will start next year, early next year, 32G per second per lane. So when you use 16 lanes of 32G, that will be almost half terabits. So, and very low latency of PCIe. And it's already matured and reliable. Next slide, please. Actually, the PCIe technology is already used in the car technologies. SSD for storage and ADAS and infotainment, information and entertainment. So this technology already start using the PCIe technique. Next slide, please. So how Annitsu can contribute this requirement? Next slide, please. Annitsu is the one of the top vendors to provide the bit error rate testers for high-speed serial bus industries. And it has this MP1900. It supports multi-channel PAM4 and NRZ BR measurement. Of course, it includes PAM3. And it supports up to 128 gigabit per second per lane. You can configure up to 16 lanes of 32G. That is half terabits. And it supports PCIe, USB, Thunderbolt link training. So it's protocol aware, equalization, and LTSSM. It supports all three clock architectures: common clock, separate clock with SSC, and separate clock with no SSC. The signal integrity is our great advantage. Very long intrinsic jitter and very fast TRTF. The PPG, pulse pattern generator, has 10 tap emphasis, and each can be adjusted plus minus 20 dB completely independently. The error detector side has 12 dB CTLE equalizer and embedded clock data recovery. So everything is in one box, and you can inject jitter, 2-tone of sinusoidal jitter, random jitter, PUJ to simulate crosstalk, half-period jitter, SSC, and vertical noise, common mode noise, differential mode noise, and white noise. So everything is in one box. You don't need any external box. We support these applications: PCIe 1 to 5, Thunderbolt, USB, IEEE, InfiniBand, and optical module SSAS. Please go to the next slide. Actually, Annitsu is the Annitsu MP1900 BERT. It's the official test equipment for PCIe, USB, Thunderbolt. Also, official test equipment for InfiniBand. And we are also contributing IEEE and OIF. So, this is new concept for automotive industry, but please contact us. And we are more than happy to provide any help for the measurement.